point-slope form looks the most complicated, but it's really not that bad. Now, slope-intercept form tells you a slope and an intercept. Point-slope form tells you a point and the slope. All right, so if you look at the formula, it says y minus y1 equals m times x minus x1. Now, the y1 is going to be your y coordinate. The x1 will be your x coordinate. And just like before, the m is your slope. But if you look, it has subtraction built into the formula. So pulling the coordinate out is kind of the opposite. So if you were to see like y minus 4 equals 2 times x minus 11, it says y minus 4, your y coordinate will actually be positive 4. And again, that's because there is subtraction built into the original formula. So it's kind of like the opposite of. And then it says x minus 11, so our x coordinate would be positive 11. Here's a point, and then the slope would be 2, or 2 over 1. Now this is all the information you're going to need to graph a line. You need 2 points, essentially, to graph a line. So you can get the point from the formula, and then you use your slope to move and find the next point. That's how we're going to do it. Now you might think, why would we learn another form to graph these in? This works great for when we do parallel and perpendicular lines, which is coming up here in a minute. Well, in a few days. All right, graph the equation y minus 5 equals 1/2 times x minus 2. So if you look for a coordinate, remember it's the opposite. So if you see x minus 2, our x will be positive 2. If you see y minus 5, our y will be positive 5. And then the 1/2 is our slope. So you go to the point, 2, 5. There's 1 point, and then you use the slope to find another point. You go up 1 over 2. If you want, you can go back 1 or down 1, left 2. It can get a little confusing sometimes, though, if you're going that opposite direction, so be careful. 3. Find the point, use the slope. Let's try another one of those. Negative 2/3 x plus 2, and you have the y minus 5. So now it says plus 2 with the x, which means our x coordinate would be negative 2. It says y minus 5, so our y coordinate would be positive 5, and our slope is negative 2/3. So find the point first, negative 2, 5, and then use your slope to find the next point, down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. Wasn't too bad, right? So now they're going to give us the information, and we're going to put it into the slope-intercept formula. Write the equation of the line that has a slope negative 3 that passes through the point negative 1, 7. So think of this like a fill-in-the-blank problem. We'll have y minus our y coordinate equals our slope times x minus our x coordinate. Now, negative 1, 7, which one of those is our y coordinate? 7. Here is the slope, which they told us was negative 3. And then x minus our x coordinate, negative 1. So all we're going to do now is clean up if we have a minus negative, which you know from when we were calculating slope, we change minus negatives to plus positive. So that's the only thing we're going to change. Y minus 7 equals negative 3 times x plus 1. Now eventually we're going to have problems that'll say like, here it is in point-slope form, get it into slope-intercept form. So you would distribute that slope and then get rid of the minus 7. And then it might even say get it into standard form. So you get rid of any fractions and decimals and get the x on the same side with the y. You're going to love it. I can't wait. So again, you can think of it like that fill-in-the-blank problem if that helps. Or once you remember, it's always opposite. You can kind of go straight to the answer. So y, let's see our y coordinate here. It says our y is negative 8. So it would be minus negative 8. So we're just going to change it right away to plus 8 equals, our slope is 2/5, and then we have x, and our x coordinate is positive 10, so it'll say x minus 10. This is our final answer. Yes! Yes! Oh, they're giving us a graph, and we have to figure out what it is in point-slope form. Now, the cool thing about this is they gave us a point, so we're just missing a slope. So the nice thing when it's already graphed is you could just count the slope. Sometimes they'll give you these problems without the graph, so you would have to actually calculate the slope, and that's a bit of an extra curveball there. But we could just count our slope from these points. This is up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3. So our slope is 8/3. Now you can use either one of these two coordinates. So let's say we chose to use -1, -5. Now which one of those is the y? The -5. So it would say y plus 5 equals 8/3. And then the -1 is our x coordinate, so it would say x plus 1. This is a perfect answer. If we chose to use the other coordinate instead, you can say y minus, our y coordinate would be 3, equals 8/3 times x minus our x coordinate, which is 2. Both of these are perfect, and believe it or not, they should be the same equation up the line. So if you were to distribute here, we have y plus 5 equals 8/3 x plus 8/3. And then you're like, okay, well, let's clear the fractions. Multiply everything by 3, that'd be 3y plus 15 equals 8x plus 8. And then if you're like, well, what is that in standard form? Woo. There we go. Or let's get it into slope-intercept form. So you would just subtract the 15, 3y equals 8x minus 7, and then you would divide by the 3. So you get y equals 8/3 x minus 7/3. Weird. There it is in slope-intercept form. Let's see if that would come out the same way on this one. It should, if I've done it correctly. So y minus 3 equals 8/3 x minus 16/3. If we multiply everything by that common denominator of 3, we'd have 3y minus 9 equals 8x minus 16. And then we can get rid of the minus 9 by adding 9, which will give us 3y equals 8x minus 7, which is the same thing I have in blue over here. So if we were to divide everything by 3, it would still work out the same way. Y equals 8/3 x minus 7/3. So see how either coordinate that we chose, it worked out to give you the same equation. Even though it looks different, it gives you the same line when you graph them. Cool? So we've got some stuff to practice. Graphing in point-slope form is very important. Also being able to move equations around is very important in point-slope form.